It's review day. Today I'm going to be doing a review on the BIQU Nebula. If you saw my previous video, you would know that I have installed this on my Voron printer using the modified Filamatrix system that was offered by BIQU. It's on their website. But now I've actually done some real-world printing. I've been using this for a couple months now, and I want to do, show you all the pluses and minuses that I found, what I think about this, and, to help you if you guys are kind of teeter-tottering back and forth if you should get it or not, or if it's something for you. This video might help. So if you're interested in that, follow along. But before I dive too deep into that, let's get a quick word from our sponsor in, and we'll be right back.
Do you need high quality 3D printing for your next project? Well, PCBWay's got you covered. With PCBWay's rapid prototyping service, you can bring your ideas to life in a huge range of materials, from durable plastics to sleek metals, all with precision down to the tiniest detail. Whether you're making functional parts, prototypes, or just something cool for your desk, PCBWay offers multiple 3D printing technologies like SLA, SLS, and FDM, all at compatible prices. Simply upload your design, choose your options, and PCBWay will handle the rest. It's fast, reliable, and shipped straight to your door. Turn your ideas into reality with PCBWay's 3D printing service. Check out the link in the description and start creating today.
Okay, so the BIQU Nebula. If you haven't seen my previous video, I recommend checking it out. I'll put it up in the little card or wherever those things pop up, and you can check that out to see a little more of the in-depth where I go and completely tear this thing down so you can see what's inside. Obviously, this is set up, so I'm not going to do that in this video, but if you're interested, check that other video out. So today's video, like I said, I'm going to be doing the review, what I feel about this, and what I think is pluses and minuses, I suppose. So first things first, what is the Nebula? It is this tiny little guy in here. It is an extruder. Really cool thing right off the bat that I can point out since we're right here is that it has this removable face, if I can do it with one hand. It's just held on by some magnets here, so get that off. And it's nice. It's just a cover to keep dust and stuff out, and it allows you to get quick, easy access if you get a little bit of like stuff built up in here, some sort of filament dust or something, so you can clean it out. And I guess to help, you can release and use tweezers to get if you have a tiny little bit of jam stuck on the gears. So that's a cool little feature. You don't have to remove everything to get some access. Obviously, if you have a super jam or you got like TPU all wrapped around things, you're going to have to disassemble. That's just the way it is with extruders, right? But it's cool because it gives you a nice view of the path even when it's installed. Another cool thing, which I honestly don't use because I'm using with the stealth burner here, there are two little LEDs inside here that are controllable. They're RGB LEDs, so you can go ahead and do all the fancy lights and stuff. But of course, if you're doing a stealth burner, as you see, it's completely covered up. So those aren't really useful for that setup. But I've seen other modifications now. People are using things like, I think like the, what is it called? The ant head, if I remember correctly. Some of the other ones where the extruder is very exposed and open. So it's really nice to have the LEDs right on top. Cool feature. Does it give you better printing? Well, of course, right? LEDs make you go faster. But no, really, it's just cool stuff to have for, notifications of what it's doing and whatnot. The cool features, in my opinion, on this one, though, are two main, I guess, switches that are built into this. There's one that's right back here. Actually, I can lift this up and show it. And there's that one right there. And that one is really, it's just a switch. So, I mean, you can program it to do whatever you want. But its original idea, as you can see, it's got this arrow pointing out. It's actually designed to be set up as a retract or to remove the filament. So you want to swap out a color or something like that. You could press that and it automatically goes through a sequence. And I'll show you in a few minutes here. And it goes through a sequence to purge and to remove the material, which I have just kind of floating out here for right now. The other sensor, which you can't see, is inside. And it's basically the opposite of what this button is. So when you put the filament down inside, it triggers a little switch inside there. And it acts as a dual purpose. It tells the machine, it can send back that there is filament in there. So it's a filament runout sensor. But at first like when you first put the material in, it acts as a trigger to load the filament. So it'll automatically start grabbing it and pushing it through. So no more having to release tension and fiddle in to get it going in. You just push it down inside and it automatically starts loading, which is really nice. Again, which I will show you here in a minute. The way they've set it up is really simple. You have this little plug at the very top. So you got your power and ground. And then there's the three different wires. So the yellow one on this far side is for the LEDs, which I'm not using right now. And then the other two are for the this button and the internal one. And I'm trying to remember the order. I think the green one is for this button and the blue one is that. But we'll look at the schematics or the pinout in a little while, so you can see the differences. Or check out that other video. I think I go exactly over which is which there. And so, yeah, I'll show you the configs and stuff soon. But anyway, so that's pretty much all they are, and everything is nicely compact right in there, so easy to sort back to your either printer main board, or what I have here is like a EBB board. The other cable, which you can't see in here, of course, is covered by this, is the motor cable. So really simple. It plugs in back here. It's just straightforward. Nothing special about that. And that's really the extruder. Now, the strong points of it, I think, are the way that these gears are set up. They got a double, like they come together like this, and they stay together really nice. There's a lot of good even pressure on it, instead of having one of them pressing against the smoother roller or something like that, like other gears would be set up as. So they're also very large. I honestly, I don't know if that's really that big of a deal, because contact is still going to be the tiniest spot there. I mean, you might have a small percent of increase of contact area compared to the smaller gears that are in normal, or those little hob gears that are in there. So I don't know if that's really benefit or not. I know some people say it is, others say they don't, that it's not. Honestly, I can't see a massive reason why you should do that, but that doesn't take away from this extruder, because like I'll show you here soon, is that it does print very nicely, really smooth and even. So something good is happening there. I think also the fact that everything is in parallel, or not parallel, but it's symmetrical. So you don't have the motor off to one side, putting really hard pressure on one side only, where the other one's kind of floating. So it's got a good symmetrical pressure. And you can see that when we pull out the filament. I'm not sure if my camera will actually pick it up on this red material, but let's see if I can zoom in on this. No, I don't think it's going to pick that up, but the grip pattern on it, is really even and nice. So yeah, there's that. So let's zoom in. I'm going to go ahead. It's going to get a little noisy because the fan is going to turn on for the heatsink cooling fan, but I'm going to turn on the heat just enough so I can get this to purge and do its thing. So you can see that in action, and I can demonstrate what I mean about the self-loading. So let's get this. I'm just going to pump it up to about 150. I think it's where my minimum set is. This is a standard PLA. Specifically, if you're interested in it, it's Polymaker's Pan Chroma, which is, I've been really happy with this so far. Not a sponsor or anything like that. Polymaker, if you ever happen to see a video of mine, I would love some sponsorship, but no, it's this is just, I bought this and I've been really happy with this material. I bought a couple other colors now already. It prints really well, which that's what I'm going to show you in my demonstration prints shortly here. But let's get this. It's up to temperature now. So I'm going to zoom in so you can see the gears here first. Yeah, I know. I'm working on saving money to get some better camera equipment and stuff like that, so I can get better shots like this for you, hopefully soon. But this is what I'm working with now. But anyway, so as you can see, you have a tiny little gap right in between there, and then it has a plastic, I guess, retainer tube that goes up and down, and one that comes from underneath and over. So it's a very small zone, and they're cut away on the sides, of course, so the gears interface with them. But it's nice because it pushes the filament in a very smooth path here. So let's get this put into there and you'll see what happens. So all I'm doing is entering the material and it automatically grabbed. And as you can see, a little redness there. And if I zoom out, you'll see shortly, it starts purging. And this is all set up as a macro. So that button that's built inside here is set to do all of that for you. So now it's ready to go. Really cool. Now, for reverse is really nice also, because all you have to do, you have the Filamatrix thing on this. Now this, of course, if you've built it like this, where you have the Filamatrix or the some sort of filament cutter system, I mean, that's really where a lot of these things are going now, right? With multicolors and stuff. I don't have a multicolor system yet. I'm hoping soon I can afford one. But yeah, so basically I have this set up to where I just cut the filament, and it's the way the macro setup is nice, because you cut it first. So now in between here, the blade has cut the material from the hot end, and then you press the button and it'll push first down. And what that does is it pushes that extra piece that I cut off a little bit further down to purge most of it out. And it's purging down below. And now it retracts at a little bit higher speed, and then it's out, and that's it. So it's a really nice, handy feature. You don't have to use any of these. You don't have to pull on your filament or anything like that. It's a very easy self-loading, self-unloading system. And of course, with multi-material systems, you can have it to where it's set up with the macro. So you can just do a cut and then basically trigger the macro that's attached to that button, and it'll do its thing. And then you do the rest with the other stuff. So it's really nice setup. And what's cool is BIQU Tech has, or BIQU has set up the macro for you. So all you have to do is modify little things here. And that's where I come to my first, I guess, gripe is in that macro. It has nothing really to do with this per se, but the speed that they have for the retract. First, I was using it before cutting, and I think that might have caused too much tension as it was pulling up. There was some melted material still, and it would like get slightly jammed there. So it is recommended to cut first. But the speed for retract was like at 50 or 60 millimeters per second. And because this is an 11-to-1 ratio or something in that range, that's really fast for the motor to retract. And so it would actually stall, or you would hear it like jam up. It would skip and just make a bunch of noise, and it would stop moving. So I had to slow down that speed, which was super easy. All you have to do is change the value, which I'll show you in the macro shortly here. But that's really the extruder. It's not really, a super technical system. The way that they've done everything in a very compact and light extruder system is really its strong point. It is also, speaking of strong, like I said, it's an 11-to-1 ratio, so it's got quite a bit of pushing power. So you're not going to have the skip-stepped issues or problems with any type of materials. Although you should be melting your material at the proper heat anyway, so you shouldn't have need a whole lot of pressing power, but it's available there, so it's a bonus. So enough of that of the direct. Let's show you how I got these things plugged in, and so you can get that stuff done if you want to do that. And I'll show you the macros and point out the parts where I mentioned about the speed. Let's go over to the computer. Okay, so before we drop into the I guess the configs and stuff like that, I wanted to show off the print quality, because obviously when we're coming into extruders, that's what's most important, right? How do these things actually print? So as you can see here, I got a couple of little things that I've already shown. If you follow in my channel, you see in my shorts that I've shown some of these things already. But yeah, let's get into the quick stuff. First things first is, God, I love this thing. It's just such a simple thing, but look how satisfying that is. It's really neat. I'm sure you've seen these things if you follow printing stuff, but man, and then I don't know if my microphone's picking that up, but pretty cool. Anyways, enough of that. So let's see the quality. And now I will point out, obviously, this red is probably the worst material to be using because it seems to blow out my camera. It's pretty wild. Oversaturated. Maybe I can post-process that. I don't know. But so let's see if we can get some of these lines in here so you can see. Now I'm using a very harsh side lighting here to kind of point out really exactly what this material is doing and what the lines look like. So there you go. So I mean, you got tiny little VFDs, which is of course has nothing to do with that extruder, but flow rate, there you go. You can see the lines there now. See all those layers? Everything is really nice and even. I've been really happy with it, honestly. I'm not going to complain about the print quality on this thing at all. And honestly, this is with very minimal tuning. All I did was the standard Orca slicer tuning that's built in, ran them one time, and that is it. I haven't done anything else. Obviously, different materials are going to need different tuning and whatnot, but that's all I've done. And I've printed with the same profile for both ABS and this PLA. And the only thing changing is the temperature and speeds and stuff. So other than that, all the other flow rates and everything have stayed the same. And I've been really happy with it. As you can see, the layer lines are very smooth and even. No weird, sometimes you get like where the extruder gear is offset or something like that. And so you'll get you can see the bumping happening in the layer lines. I don't notice anything like that. Here's another one. You can see, obviously, we got some stuff coming on from the different speeds that it hits, depending on where it's changing. So you got some thicker and thinner things going on there. But overall, I mean, even under this harshest light, there we go. There's the nastiest that you can see this thing at. So relatively very nice and even. Most of these type of lines are, as you can see here, it's in line with that speed change. This one is in line with that speed change. So they're all in there, and these type of lines are visible in the slicer too. You can see that it's all speed change stuff. So I'm not gonna blame that on the extruder, because when I have, as you can see here, a very consistent speed, you don't get any of that. All of these were printed pretty much the exact same speed in the slicer. And trying to find anywhere where the harshest light is there. I guess that's there. So as you can see, it's very nice and smooth. So yeah, print quality on this thing, I've been really happy with. So I can't complain there. Honestly, I'm sorry. I normally want to try to do something and say, you know, well, they need to fix this or that. But it's doing great. This is my new permanent extruder for this machine. Here's a very simple part that I made. So you can see there's not much speed change issues going on there. There's a VFD on my, for some reason I got it on my Y axis. I don't understand why. It's a Core XY, but only the Y gets these, not the X. So I'm hunting down what's going on there, and it's only on one side, as you can see. So anybody have an idea on that, go ahead and drop that in the comments. That'd be interesting to know about. But it's only on the side that faces, or I guess it would be on the positive Y side, or positive X side for the Y direction. Kind of strange. Anyways, there's that. But otherwise, I mean, as you see, it's buttery smooth. Those lines are really nice. So the extruder prints really well. Very nice, even flow. No issues whatsoever. So let's show you how things get plugged in and set up. Okay, so here I am. I'm just showing the BIQU wiki page, which is a pretty easily place to go for finding out all the information about these different things. So here I am on the Nebula one, as you can see up here. And then I've scrolled down just to see the button section. So as you can see, like I mentioned, those wires up on top, I got them switched up. So the first one, which was the, what is that, the green one, I think it was, that one is going to the filament sensors. That's the one that's built inside. And then the GB, that's for this one. They call it a G-code button. So you don't have to leave it at the filament unload if you don't care to have a filament unload, or you have a different way of doing unloading. You can obviously, if you have a Klipper screen setup, you can have it there. So you can make this something else. So if you want to click this and have it as a preheat, you can do that. So it's really nice. So all it is it's literally just a button. So you can tell Klipper to do whatever you want with that trigger. So when you press it, let go, it does something. But as you can see, very simple wiring. You got your 5 volts in and ground and all that good stuff. And then the RGB is the last one. So where do you plug these things in? Now, because of the way this extruder is set up, it's designed to use the EBB36. So that's one thing I do want to point out. If you're used to using the stealth burner with the SB 2209, 2204, the one that sits on the side and then plugs into your fan, that one's not going to work. And the main reason why is because this is a central, it's very nicely symmetrical the way it's set in there. And so there's not enough room for that to basically go off the side and still plug into the right zones. I'm sure somebody can modify it to where you can just use a flexible cable to plug into the other thing if you want to continue using that. But for me personally, I just use the standard EBB36 on the back. It works just fine in my opinion. But there's that. Just want to point that out. I guess that would be a gripe about that. This extruder is that you can't use the EBB or the SB 2209. That one specifically made for stealth burners. So enough of that. But yeah, to get these plugged in, it's really simple. Let's switch over to the EBB. This is the CAN model. And it's really nice because they've designed this end stop port. And I've noticed, and the reason why I'm pointing this out is I've noticed that a lot of people don't seem to understand that these 3 pins can be used from different things. They don't have to be only for end stops. And so, like I mentioned with that, those are buttons. You can plug those into here. So you have your PB6, 5, and 7. And those correspond to these 3 pins here. The first one is your 5 volt and ground. So all you would have to do is wire up the plugs to basically match where they go. I mean, obviously, guys, if you guys are coming to this part and you're installing something like this, you probably should already know, or you do already know. So this is just blah blah blah. But every day I encounter people saying, I don't understand why this isn't working, or how do I get this to work? There's no port for it. They're looking for basically a special port made only for this plug here. And that's just not how that works. So the first 4, you'll be able to get into the end stop, but the last one is RGB. That's where your LEDs. That needs to go to a different one. And obviously that needs to go to the RGB port here. So yeah, as you see, they both have 5 volt and ground. So you can choose which ones you want to plug the 5 volt the 5 volt and ground from here, they are technically attached to the same lines. So that does not matter. But the PD3, this center pin, is where you have to plug in the LED. And the reason why is because on this chipboard, there's a special driver. I think it's this little guy right here. But basically, there's a system set up to where it translates the 5 volt down to a 3.3 for the LEDs, so it doesn't burn things out. Everything communicates smoothly. And that's why you can't just put them on whatever pins. I mean, it kind of will work if you want to put it on there too. But the issue is that these have pull-ups. So I don't honestly think it's a smart thing to plug in RGB data pin onto something that has a 3.3 volt pull-up on it. And what that means is that there's a resistor from the pin to the 3.3 volt power converter. And so if there's no signal, it pulls it up and it keeps it high all the time. And that's just the way these things work. Getting a little technical. If you're interested in learning more about that, of course, drop a comment down below and I'll be happy to explain, or maybe do a future video on what the importance of that is. Probably something good to know anyways when you guys are starting out. But besides that, that's why I wanted to point out to don't use the RGB on this last one. Only use the buttons on these here. Make sure the RGB goes over here. Pretty straightforward, right? Very easy to install, really simple. And that's all it is to it. Of course, you have your motor goes in there. That's done. No brainer on that. You don't have to rewire it. The motor is designed to plug direct. So it's really simple to do. And really that's the kind of same configurations depending on, or regardless of which board you plug it into. If you're going to go straight to the board, to a motherboard, you're not going to use one of these. You're going to go through a cable chain and do it that way. Let's just go to one of those. So we'll go back over, let's see, let's just do the standard SKR series. So we got the newest SKR3. Let's just say you have one of these. And then it's kind of the same idea, only obviously you'll have to find which pins do what. So there's your pin out diagram and the same thing. So you have your RGB. So same idea, 5 volt and ground, and then you got your PE6, which is in the middle. That's this little port right here. So the middle one will be for your LED, that yellow wire. And then you got your end stops. Now, end stops are different on these than the toolhead boards because they obviously have the XYZ end stops, and then there's other stuff. So this one specifically, the SKR3, has two E1 and E0 detects. So those are typically what are used for filament runout sensors and so on. So these two ports, which are right here and right here, is what you would use. Now, keep in mind, if you use the power, say for instance, you're not using the RGB like I'm not. You don't have the power here, you have it going somewhere else. So you do have the power. You do not need to provide power from both. Okay, so you don't have to split the cables. These here, this 5 volt, anywhere actually you see 5 volt marked on anywhere on these pins, they're all on the same rail. So it's, you can just imagine that it's all one solid line that you're just adding more wires to. Same with the grounds. All the grounds are tied together everywhere else. So all you have to do is plug in the first one. So you got 5 volt ground and PC2 on this one, for instance. That's this port right here. So you would wire it to the first three, 5 volt ground and FS. Then the next one, the next wire, the GB, will come out and then come down to the next port. And all you will have plugged into this port is just this PA0, that one pin. These two will be left empty. So yeah, it's a 3-port thing, but you only have the one wire going to this thing here, whereas you have the other 3 there. And then if you're using RGB, you would have the one yellow wire coming to this one right there. And like I said, since power is done, you don't have to worry about those. They're all connected together anyways. So that's how you would do it on this type of a board, or any of the boards that have multiple ports. That's again, a bunch of times I've seen the questions coming up, how am I supposed to plug this in? It doesn't have the right port. I don't have that. Where am I supposed to plug these in? It's junk, blah, blah, blah. That's how you do it. You have to split the cables along these ports. And it's okay for you to have, like I said on this one, only the sense pin connected, nothing else. So that's not a big deal. So that's how you do it. It's really, really easy. I can't really go any deeper than that because that's all it takes. And then, of course, you have your motor. So you'll be on your extruder motors down here if you don't have a tool head. And so you have that port there. Again, really simple, straightforward, plug it in, doesn't need any rewiring if you're using Big Tree Tech stuff because they're designed to be, cross-compatible, or they attach to each other without any issues. The biggest rewire is going to be dependent on where you want your pins to be attached to. For instance, if you have these in use, Obviously, you have others. If you have something empty, you can use those pins. I do recommend keeping these first two button pins on something that was designed for an end stop, mainly because of that pull up. That pull up helps it stay from what's called bouncing. When you have switches, when they're not in use, or even if they are, just slight vibrations can cause them to partially trigger. And that's what that pull up resistor is designed to do, is to stop that, accidental trigger. If for some reason you're on a board that does not have these, but it does have something like, let's see, this one doesn't. Let's just use the SKR Mini, for instance. That one has some floating pins. Yeah, I'll show you what I mean by that. These here that are marked IO right here at the top, those are basically GPIO. Those are standard. These 5 pins are designed to just be connected to whatever, and you program how you want them. And that is, let's see, do they have a wiring pin out? Yeah, there it is. So that's these 5 here that are right beneath the text that says Mini E3 IO next to it. So if, for instance, you have this board, then you can get power from anywhere. And like I said, anywhere that's a 5 volt and a ground. If you're not using the screen, or you can collect it from here. This is the SPI port. You have a 5 volt there and a ground there. So this pin is 5. That one is a ground. You also have lots of different areas you can collect the power from. Just make sure 5 volt and ground in the right spot, of course. But then all you do is make single connections there and there for the first 2, or whichever of these you want to use. But if you use these, here's the caveat with these. These do not have any pull-up resistors or pull-down. So pull-up and pull-down, basically pull-up means to take it to the voltage plus, or pull-down brings it down to ground. That's pretty much what that means. Either one is good to have, because that allows that debouncing feature to be functional, so you don't get accidental triggers. So if you use it on this board and you're not using your end stop pins, which you do have still, you have a power detect and you have the E end stop, so you can just use those right there, no problem. But if they're all in use, you have these pins that you can use for those. So that's another alternative. If you do that, you need to have a resistor also in line going to, for instance, ground is probably the safest way to do it. Don't put a resistor to 5 volt. If you're going to put it to voltage, you need to find a 3.3 volt pin. And as you can see here on the SPI, this one is marked 3.3 volt. That's right there. And the reason why I say that is because these pins are directly connected to the main chip, and the main chip runs on 3.3 volts, not 5. So do not ever connect 5 volts to anything that's directly connected to the chip, because you will burn it out. Be warned. So if you're using these, they do not have the 5 volts on them, but you need to put the 3.3 volt pull up. Okay, so that's what those are for. But I recommend staying away from that. That's like a last resort if you have no other option. Just use the end stops and you'll be safe to just plug them straight in, because they're designed to do exactly that, work on buttons. A traditional end stop is just a switch, just a button. So really simple. All right, configuration. That part was really easy because, of course, like they normally do, BIQU has set up the entire configuration for you. So you just have to make sure to have the right pin numbers, depending on where you plug them in, the right naming and everything like that. It's pretty much set up, ready to go. So all you would do is go ahead and copy this. You can copy the raw file, which will copy all the text, or you can obviously do a highlight and copy paste type of thing if you want to, but this ensures that you get the entire thing copied correctly. Then you just come into your machine and you make, in my opinion, this is the best way to do it. It's up to you, but you make a nebula.config. Just basically create file, name it, whatever you want, nebula.config, and then create, and then it'll pop it up there. And then you just paste it into that file there and you're ready to go. So really easy to do. A couple little things I want to point out, of course, that are very important are, first off, your pins. Here is the section for the LEDs that's in the nebula. Now, as you can see, I have mine commented out, and that's because like I said, I don't use them since it's on the stealth burner. But if you're using them, then you want to make sure to put the pin number here to obviously where it's plugged in on your board. Same thing goes for the unload and filament sensors, they're calling it, load unload systems, the one that's marked FS on the extruder. So you want to make sure, of course, to put those corresponding pins in there also. That's important to do. One other thing to point out is in this config, they have included the extruder information for the gear ratio and all that stuff, and the default rotational distance. I haven't changed that, and it works spot on. I went to go do the standard calibration for rotational distance, and it extruded the 100 exactly, the 100 millimeters exactly from the beginning. I tried it 3 different times, and it was dead on. So I didn't have to adjust this number, surprisingly. Normally, you have to adjust just a little bit, but it makes sense. I mean, it's on a mechanical basis, so the math works out to exactly that with this gear ratio and all that stuff. So that means that there's a very good or minimal tolerance in the gears. There's not much slop, basically. They're very tight and spot on. So that's a really nice thing. But anyways, this is where you would change your rotational distance if you want to do that. I want to point this out also because, as you can see, it's extruder, and we also have extruder. Let's back out of here. We also have extruder down here somewhere in our printer config here, right? It's okay to do that. You can have extruder in multiple places, but as you can see here, I have canceled out, or commented out this rotational distance. You cannot have these type of things in multiple areas. You'll get an error, or it just won't work. So if you put that configuration for the nebula in, and you're getting an error about multiple locations or defined twice or something like that, you have some sort of extruder error going on, check that. Make sure that you don't have these type of things double added or something like that. It can cause issues. Or another issue that you can run into is that instead of it not giving you an error, it'll just choose one ahead of the other. So it'll see probably the one that's in there, your configuration for the nebula, which is, since I'm here, I'll point out, which is included, right? Make sure to include it. It'll see this first, and then it'll start loading up the full printer config, and then later see this one if it's not commented out, and then put that. And that'll be a wrong rotational distance. So that will mean that it'll be way too slow because it needs to be a lot faster with that huge gear ratio. So keep that in mind. If things aren't looking right, or they're not moving properly, or if you're getting errors, check that you don't have things multiple defined, okay? That way it's set up properly. So anyways, that's that. Otherwise, yeah, like I said, make sure if you do double configurations or add that configuration, that you do have this include in your printer config. Otherwise, it won't see that, and those things won't work. And then, of course, save and restart, and you'll be good to go. One more thing I want to point out is, let's go back into that Nebula config. Where did it go? There you are. Is this unload speed? In my experience, that was too fast. It was at 3,000 millimeters per minute, as you can see right here, right? And that relates to approximately 50 millimeters per second. And I would have sometimes where the motor wouldn't handle it. It would kind of stall out. And that's pretty fast for that type of a gear ratio. It's trying to move the filament at 50 millimeters per second on the outside at an 11:1 ratio. So that means the motor itself is having to spin really fast. So I dropped it down to 18, and that seems to work really well. As you saw in my initial just unload feature, it works perfectly. So that's one thing I recommend. If it's not extruding, you start hearing going like really high pitched noise, it's probably because this is just too high of a speed. Drop it down, you'll be good to go. So that's it. That's the configuration. Pretty simple, right? If you have any questions, please let me know down in the comments. Hopefully this review was simple. Can I recommend the Nebula? I have to say absolutely. I love it. Dimensions, as you can see here, it's a very tiny extruder. It's got a lot of pressure on it. Oh, one more thing. This little screw, do not unscrew it. Do not back it out all the way. It will damage things. If you continue to turn, just lightly turn it. If you feel any resistance, it stops moving. That's it. Don't move anymore. You don't want to keep pushing it and unscrew it or push it out of its little screw point, okay? So the BIQU Nebula, that's my review. Will I recommend it? Yes, I like it. I really do like it, actually. I think it's great. It looks cool. It's nice, compact. It's very powerful. So it's a great little package. I can't seem to find anything, really wrong with it. It does its job well, and it seems to be working good so far. So, only time will tell how, for instance, the gears hold up and stuff, but I don't see any reason why they shouldn't hold up for quite a while. But yeah, that's that. Any questions, leave them down in the comments. you'd like to see anything more about it or want to see more prints, I'll probably do more shorts here and there. I'm trying to get more of those. Let me know what you guys think about those, if you like them or not. I know production quality is not there. That's not my strong point, but I want to get the information out and just show you what I'm printing in between my videos. Show you that I'm still alive too. Sometimes I have little gaps that are longer than I want it to be, but that's that. Big thank you to all my subscribers. You guys keep coming in. I welcome you all, and I thank you massively to all of my long-term subscribers. And I also want to give a huge shout out. This is something I haven't really mentioned on my channel. I don't even think at all. I kind of just posted quickly. Is that I have a Patreon, and I don't have anything special on there. I just have a single pledge just to help the channel. So it's just something there. And I want to welcome Steve. I'm not going to go into more than the name, of course, to keep anonymity, but thank you. Thank you so much. My first Patreon, that was a massive help. I do appreciate that. I'm not asking you guys to, or begging you guys to do any of that, but if you wanted to, it's nice. Like I said, there's no benefit. It just helps the channel to help me grow, to get more equipment, to make it better. At the moment, maybe in the future, or I should say in the future, I will try to do some sort of perks and benefits. If you guys are interested in that, let me know about that stuff. But yeah, it's there's a link somewhere on my YouTube channel for the Patreon stuff. I'm not going to push that too much because I know some people think it's kind of strange, but it is there. And I did have to give a massive thank you to my first ever Patreon. That was a super surprise. Thank you so much. That is a really big help and an honor, really. It is to have somebody doing that. That means a lot more than I can express. It's very humbling to see that happening. So thank you for that. That's gonna really help out. So anyways, enough of that. Yeah, if you guys are interested, go ahead and check that out. Also, don't forget to check out our video sponsor, PCBWay. More information down in the description, and follow them. Loads of stuff. If you want to get your stealth burner done in metal filament or metal material, you can do that. You can have an aluminum extruder. It's not going to be cheap, of course, because that process is not cheap, but yeah, you can get that if you wanted to. It'd be kind of cool. Anyways, enough. Thank you. Hopefully this was helpful, and until next time, get out there and make something. Thanks for watching.